So this is a new idea that we're beginning with in this section, and it's called partial pressure. I'm not sure who decided partial pressure, but the idea behind partial pressure is that if you have a gas at one pressure, a gas at another, and a gas at a third pressure, the pressure of the first one is, and the second and the third, when you put them in the same container, you can just add up the pressures. So it's actually a really, really simple equation, but the concept feels a little weird at first. You're like, should you be allowed to do that? Oh, yeah. So, unless they react, gas like they are their gases, the ones in a mixture, they don't affect each other's pressure. So each just will exert the same pressure as it would have alone, but pressures are additive. So we're going to assume that those little dots are moles, and we're going to assume that every one of the dots really did make it into this container over here. So we're going to just double check how many moles are there in each flask. So I'll pause, or you pause the video, and count the different numbers of dots. All right, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, what's the total number of moles in the container? You just add those up. So you can count them yourself, or we can just add them. 27 plus 13 is really easy. That gives us 40 plus 19. That gives us 59 moles in that container. All right, so here's the interesting part. What fraction of dots are there on the right that are orange? It didn't just want to know how many, what fraction. So it's 27 of 59, 13 of 59, and 19 of 59. So if you multiply each fraction times the pressure, what are the numbers in the answer? So here's the pressure. So for the blue, it wants to know times the whole pressure, not the partials, times this pressure here. So if we want to know how much of this pressure comes from, say, the blue ones or the purple ones or the orange ones, like if we want to know how much of each of those pressures come from the different spots, well, there is a way to tell. All you have to do is take, let's try the orange, 27 over 59 times that pressure, and you'll get a total pressure. 27 divided by 59 times 1350. That is the pressure that I'm going to call it 618 kPAs. That's the pressure that the orange moles are exerting on that container. Then if we want to figure out the pressure of the next section, we just do the same numbers. So we do 13 divided by 59 times 1350, and we get, that's times, let's do 13 divided by 59 times 1350, and we get, let's try it for a third time, 13 divided by 59 times 1350, and that gives us 297.5. And that's kPa. So that's how much is due to the blue. And to find out how much is due to the purple, 19 divided by 59 times 1350, 434.7 whatever kPas. I wasn't watching my sig figs on these. I probably should have kept all the sig figs at a total of 3 sig figs. So we'll make that 298, and we'll make that 435. All right, here's the point though. If you know the total pressure of something, and you know this is called a mole fraction. You know why it's a mole fraction? Because that's the total number of moles, and that's part of it. So it's like any other fraction, and it's made up of moles. So mole fraction is one thing we're going to learn. There's an X, and it's part moles over the total moles, like any other fraction. So we were just using mole fraction times the total pressure gives us the partial pressure. And guess what? All three of those pressures that I'm drawing squares around, they add up to the total pressure. So let's try this with some problems. So there's a few different parts of problems. Some of these are worked out and some of them aren't worked out. So these are good demonstrations though. What is the total pressure of a mixture of gases in a container? Of course they're going to be in a container because they're a gas, right? A lot of times this doesn't have to matter. What is the total pressure if they have a partial pressure of this value, and this value? Yeah, there are 3 gases in the container. They each have a pressure. You just add them up. So 0.5 plus 0.75 plus 0.05. That's going to give us 0. Carry the 1, 1.30. Now sig fig wise, our sig figs are going to fall like that. So that gives us 1.3 ATMs. That's the total pressure right there. See, that's easy. So let's go ahead and see what happens if we need to figure out moles. So the next one, we have this many moles of radon and this many moles of hydrogen in a container. Here's the temperature. Notice that's in Celsius. How much partial pressure does each exert? Okay, so listen, they're a mixture, so that's why we say they have a total pressure, but you can figure out each gas's individual pressure. That's what partial pressure is. It's just the individual gas's pressure. All you have to use is PV equals nRT. So we're solving for the pressure, and we've got it rearranged, nRT over V. So here's our moles right there of radon. We already know our R value. We have the temperature. Remember, it's converted into Kelvin there. And then we have the volume. So you just do that, and you figure out how many moles of Ra that you have. Now, on your own, go ahead and rework this problem and figure out how many moles of hydrogen. That's what the second P is for. It's going to be very, very similar. And then go ahead and work part B, the pressure the mixture exerts. This means the total pressure.